and I love to write some code in Go as well. And I'm quite in the community, active in the community. I work as a Logstash community maintainer, and in this role I maintain 2 Logstash plugins. And also I'm contributor to the Logstash filter verifier, a tool I will show you later in this presentation, and some other open source stuff which we will see later in the presentation. So how is Swisscom using the Elasticsearch within the Swisscom Application Cloud? There are mainly 3 use cases. The first one was already mentioned by Lucas, is this ELK as a service. This is a combined package containing Elasticsearch, Kibana, and Logstash. And the main use case is for all the cloud native applications which run within the application cloud of Swisscom. You're able to stream the logs, store them in Elasticsearch, and finally have a look at them with Kibana. Then there is a second use case. We are currently developing Elasticsearch Enterprise, so a backend service only containing Elasticsearch, where a broader use case or more use cases may be addressed with this. Also classical full-text search, as Nicolas mentioned, or metrics, or also geolocation capabilities could be used in this case. So every customer which uses this service in the future will be able to have full control over the Elasticsearch cluster. And the third use case, I assume that mostly everyone which gets in touch with Elasticsearch finally ends up using it also for log data. So it's the same for the Swisscom Application Cloud. We use it to gather all the infrastructure logs which are generated by the services we run. So I will show you in the next few minutes how you can use Elasticsearch within the application cloud, and how you can stream logs from an application which you deploy in Swisscom Application Cloud to this Elasticsearch, and have a look at it with Kibana. As Lucas already mentioned, in Cloud Foundry you run cloud native applications, and all these instances are ephemeral, so you don't have any guarantees that they will be around, and storing local data is not really a good idea. So you really have to stream the logs away from your instance to a central place where they are stored. And also one of the advantages if you use Swisscom Application Cloud is it's very easy to scale your application to tens or hundreds of instances, and if you do so, it's quite hard to get an overview over all the logs, because every other request goes to another instance, and if you want to follow what's going on, you have to really centralize these logs in a central place. Yes, and also it's encouraged to develop cloud native apps as 12-factor applications. This is a methodology, and one of these factors also defines how you should work with log data, and there is really no need for such applications in the cloud to concern itself with log data, but only to write them to standard out, where the platform, in our case Cloud Foundry, picks these logs up and forward them to a central place where they might be retrieved over an API. And for Cloud Foundry, there is a thing called customer provided service, and this we will use today to stream the logs generated by a demo application to an Elasticsearch instance. So what we want to see is we have an application. We will deploy it to Swisscom Application Cloud. We will use this customer-provided service to link together the application with Logstash, where we are able to filter the log and modify it, and finally store it within Elasticsearch, a service provided by the Swisscom Application Cloud. And finally, we will have a look at the log data with our Kibana application also deployed in Swisscom Application Cloud. As I already mentioned, it's very easy to scale those applications, so we will see how we can scale, for example, the application which generates the logs. There are also other use cases you could tackle with Swisscom Application Cloud. You could deploy your application also for housekeeping. Some of you might know Curator, or you could also deploy other dashboards like Cerebro or Kopf, which give you more insight what's going on inside your Elasticsearch cluster. Just a few words about Cloud Foundry Build Pack. Cloud Foundry Build Pack is like the framework which is used to get the applications you push to the application cloud running. So this framework defines which components are needed. For example, if you push a Java application, you need a Java runtime, or if you deploy a Node.js application, you need Node.js to run it. And those build packs collect the necessary dependencies and then run the application. And for most programming languages, there are predefined build packs, so you don't have to care anything about those. And for Logstash and for Kibana, because those are specialized applications and they are not developed like cloud native applications, it was necessary to create its own build pack to deploy these applications. Okay, so now switch to the console. Okay, I hope it's readable. So what I have, what I have in this directory is a small application. It's written in Go, and its main purpose is to start a web server with a very rudimentary UI, and its main purpose is to generate logs. So we can build this application and we can run it on localhost. So it's running at the moment on my machine, and it suddenly starts to generate some log data. And if I switch to the browser, I can access it on my machine, and I have the possibility to switch the interval in which new log lines are emitted. So as I said, this was on my machine, and now we push this application to the Swisscom Application Cloud. For this, I'm already logged in on my machine here, and we can see that I'm connected to this endpoint and authorized as user Lucas Bremgartner. And all the applications within the Swisscom Application Cloud are organized in organizations and spaces. And here it says I'm working in this sandbox organization. Now we can just push the source code. So let me just delete the binary first, because this is not needed. And we push this application. So what's now going on is the source code of my application is pushed to Swisscom Application Cloud, and the build pack, which is there for Go application. Oh shit, okay. Demo gods are not happy. Just a second. I already had the service in my manifest, which I will later bind. So at the moment this service is not there yet, so this failed, but now it's working. So this command, cf push, ships the source code to Swisscom Application Cloud. There the binary is built and finally started, and we can access this application. While this is working in the background, I also push the Kibana application. As I already mentioned, this Kibana application uses a specialized build pack. It's also available on GitHub in the Swisscom organization. So now in the upper window, the deployment of our log generator application has finished. And if I switch to my browser here, I'm able to access this application. Nothing fancy here, but now if I say for example 5, so now with this simple command I just scaled this log generator application from 1 instance to 5, and if I refresh in the browser you see the number switching. This is the instance number, and all these 5 instances are now running. And if I access the logs of this application, we see that all the different instances emit a log line each second. So if I stop here, you can see here already the index of these different applications, and all they are emitting log lines. Okay, so now the next step is to deploy Logstash as well. So I have to change to Logstash. Yeah. So let's have a quick look. This Logstash application consists of several directories, and the most interesting directory is the conf directory, where the actual configuration of Logstash is stored. So all of you who are already familiar with Logstash know this file format, and this configuration is now pushed to the Swisscom Application Cloud. This takes roughly 2 minutes, so I let it work in the background. And now I also have to create this customer provided service. So what this does, you see it here. This is also a Cloud Foundry command, which creates a customer provided service with this name, and it binds it to this address. And this is the address where the Logstash instance, which gets deployed in the lower area of the screen, will listen for new log lines to arrive. So now let me create this service as well. Okay, so normally if you create a service, for example a new instance of Elasticsearch, it takes some minutes to really ramp up this service, but in this case it's only an address, so this is quite fast. And while this is still deploying, I switch to developer.swisscom.com. This is the site Lucas already mentioned, where the offering for Swisscom Application Cloud is presented. And here I can enter the portal and have a UI version of all the stuff I used with the CLI before. So what we see here is the ELK instance. This is the service which gives me the Elasticsearch. I already created it before the presentation, and now I deployed this log generator application. I deployed the Kibana application, and also I deployed this Logstash application, and we created the service binding which connects the log generator with Logstash. So now I assume, yes, this is finished. And for the log generator application to pick up its new service binding, I redeploy it. And if everything is working like expected, we finally should have a Kibana dashboard here, and in some minutes we should also get some log data. Oops. So here we have some old data from the test drive, but now it's still deploying, so no logs yet. No. Okay, my fault. This will not work because I have to re-enable the service again. Okay. I let this run in the background, and we will look at the result a little bit later. Okay, and I will start with the second part. So, who of you is working with Logstash for log shipping? Okay, and who of you has a Logstash configuration with more than, let's say, 500 lines of configuration? More than 1,000 lines? Okay, if you have Logstash configurations with more and more lines, things become more and more difficult to maintain, especially if you keep adding more and more services. And I would like to show you how we test, kind of unit test Logstash configurations within Swisscom. So first, short look on our setup. It's really the classical one. On the left-hand side, we have beats on the edge nodes. So the edge nodes in our case are nodes provided by Cloud Foundry, computing nodes, but also all the services, MariaDB, MongoDB, and stuff like this, and also background things. We need DNS servers, for example, reverse proxies, and stuff like this. So FileBeat is really deployed on all these edge nodes and pick up the log files of these daemons, ship them to a Logstash instance, and this Logstash instance we only need because of Nicholas. When do we get RabbitMQ support in FileBeats?
Need to fire me first.
Okay, bad luck for us then. Yeah, we need this Logstash instance to forward the logs to RabbitMQ. We use RabbitMQ to handle back pressure, and also if there are spikes in the logging traffic, we can better handle it. Then we have Logstash filter, where the heavy lifting is going on, so all the log events arrive there are splitted into meaningful information and finally stored to Elasticsearch, and we have dashboards in Kibana to really have insights into this data. So what are the challenges if you build up such an infrastructure? Every application, every service has its own log format, and you have to tackle them all with specific logstash filters to separate the meaningful information from like the less meaningful. And while doing so, your logstash configuration becomes more and more complicated with more conditions and more edge cases, and things become really hairy if you lifecycle your software and you have different versions running in parallel, and unfortunately also the log format changed from one version to another, and you have to maintain a logstash config which tackles all these edge cases. So we really had the goal to also integrate the testing of the logstash configuration within the CI pipeline, and therefore we looked out for a tool, and yeah, luckily we found a good solution for this. Another part which gets more complicated is to maintain all the Elasticsearch mappings, so the definition how the data is stored. And I will not cover this topic, but we also put some thoughts on this, how we can manage the ever-growing Elasticsearch mapping. Yeah, so all of you, if you know Logstash, this is nothing new for you. Logstash is really input, process, output. You have a wide variety of input plugins which retrieve data. You have a filtering part where you modify events, extract important information, and you have the output side where you are able to store the data, for example, to Elasticsearch, but also to a wide variety of other solutions. And there's a huge plugins ecosystem where you can cherry pick exactly those components you really need. So for the testing of our Logstash configuration, we use a tool called Logstash Filter Verifier. You can find it on GitHub. It's written by Magnus Back, a very active member of the Logstash community. And in the README, it has this quote, if something goes wrong in the Logstash config, you might have millions of incorrectly parsed events even before you realize your mistake. So you have Logstash in production, you have few thousand events every second, and a mistake could have really a big impact on the data stored within Elasticsearch. And that's where the Logstash Filter Verifier comes in. This tool provides you a unit test kind of functionality for your Logstash configuration. And what it does is it takes your Logstash filter configuration, starts an instance of Logstash, and sends the test input and retrieves the result and compares it to the expected value. And this gives you a really good insight what's going on. So for your data which you want to test with Logstash, you have to write JSON documents which contain a test suite, and in this test suite you are able to define what data you want to send in and what result finally you expect. You can add additional fields, so for example, some of the inputs automatically add the host information from on which host an information was retrieved, and if you want to have the same behavior in your test cases, you need to add this information as well. You can add the codec, so in most cases you have log files which are line by line, but in some cases you might log JSON lines, or if the logs are already pre-processed by another Logstash instance or by FileBeat, you will have already JSON information, the information encoded in JSON. You are able to ignore some fields because you can't guess the value. For example, also this host information is dependent on the host where you actually run your tests. So it's better to ignore this information. And finally, you have the input. This is an arbitrary log line, one of this log generation tool we saw in the first part. And then on the bottom, the expected values which get extracted from this log line. So let's switch back to the console again and first have a look at Kibana, and hopefully we'll have some data in there. No. Okay, bad luck for me. Sorry?
A lot of filters enabled.
Yes, they have to be there.
Okay.
Those filters here, yes. Because if I go back in time, I have data, but I have no fresh data, so bad luck. Maybe I will figure it out later. But let's go to the filter configuration. So what I have here is such a test case. So if we go test driven, we would first write the test case with this log line we expect, and also the fields we want to strip out of this log line. And we start with completely empty logstash filter configuration. So nothing there. And if we run this, we will see that the test case is failing, and we will see why it is failing. Logstash is really a slow starter, so it takes up to 15 seconds to start, and because of Logstash filter verifier always starts one instance of Logstash, we have to wait this 15 seconds. So what we see is the expected result. The log line was sent through Logstash. We have no filter in place, so all our expected fields are actually missing, and there are fields which we don't expect at all. So fortunately, I have a working configuration. I can put it here. So what we do is we have this grok filter. Grok filter is kind of regular expression on steroids, which allows you to split a log line in pieces. So first we extract the timestamp, we extract the severity, UUID, the size of the message, and so on and so forth. And then we change the timestamp of the log event to the timestamp we extracted from the log line. And finally, we remove this temporary field where we stored the timestamp when we extracted it with the grok pattern. So now if we run it again, did I save? Yes, I saved, okay. Again, we need this 15 seconds for Logstash to start. And now we have the expected result. One test case was executed. The result of this test case was successful. So for this demo, I added some more test cases, even separated to different test sets in different files. And if I execute them, we will see that all these test cases are successful. One thing to note here is now it is run with a Unix domain socket. So in default behavior of Logstash filter verifier is to expect the input from standard in. Now the problem is you only have one standard in, and if you want to test different inputs with different behaviors, this doesn't work very well, and the solution in the past was that the Logstash filter verifier started multiple instances of Logstash, but because every instance needs this 15-second timeout, it was quite slow, and so we extended Logstash filter verifier to use these domain sockets, so we are able to send different test sets in parallel and retrieve the result much faster. So here we saw that all these test cases from the different files have been executed successfully, and now if we change to something more production, more close to production, this is a checkout of one of our configurations of Logstash, and here we use a makefile to execute all the tests, not only Logstash filter verifier, but also the Elasticsearch mapping is getting tested if it's valid JSON. This is in the upper part. Some templating stuff is going on, and finally also Logstash filter verifier is started to run all the tests against this Logstash configuration with roughly 1,000 lines of configuration. And after this 15 seconds timeout, now we see that all these test cases have been run for these different log formats. All these log formats are processed through Logstash, and you really get confidence that the configuration is doing what it is supposed to do. And as I mentioned in the beginning, our goal was also to integrate this in our CI pipeline. So we use Concourse as a CI tool, and we have different resources. One is for merge requests, so if someone changes the Logstash configuration, he can provide a merge request, and if the test is successful, it's fine to merge it to master. And here we see the same output we saw before from the make command. All these tests are getting executed, and you really get the confidence that the Logstash configuration is doing what it is supposed to do. And now, as a last quick command, all of you, if you work with Logstash, you might be familiar with the command to check the syntax of Logstash configuration. So here we have this command prefixed with time to see how long it takes. We start a Logstash instance, give it a Logstash configuration, and measure the time, how long it takes to test the syntax. Okay, to be fair, Logstash does a little bit more than just testing the syntax, but we see it takes quite some time. In this case, roughly 11-12 seconds. And also on GitHub we have a new tool which is implemented in Go and provides a full Logstash configuration parser, and with this it takes more like milliseconds to do the same thing. So as you see up here, the Logstash found out that the given configuration is invalid because there is a missing double quote, and this Go Logstash check finds the same thing. And if we change, or if we fix the configuration file, this one here, run it again. Okay, now everything is fine, and Logstash as well. Give it 12 seconds and we'll find out that it's fine as well. Okay, Logstash is also happy with the fixed configuration. Okay, so that was it from my side. Sorry for the logs not appearing in Kibana. Maybe I figure it later. Yeah, I figure it out a little bit later. Are there any questions?